Morning, am I audible to you guys?
Yes, ma'am.
So in last class, we saw basic four types of inference rule in case of first order predicate, and those are universal generalization, universal instantiation, existential generalization, and existential instantiation. Okay, so apart from this, we have some other inference rule in FOL, and one of them is the generalized modus ponens rule. So it is just your lifted version of your modus ponens. Okay. So generalized modus ponens summarizes that if P implies Q and P is asserted to be true, therefore Q must be true. So here, in case of generalized modus ponens, we call it generalized modus ponens because in generalized version, a known fact and the premise of the implication are matched only up to a substitution instead of your exact match. Premise of the implication are matched only up to a substitution instead of its exact match. So as long as we have a substitute, we can simply use your generalized version. We will not just wait for the exact match. So whole notation you can represent as like, suppose we have a P dash, we have two atomic sentences like Pi and Pi dash and Q. Okay, so here we will substitute, we will have a substitute, theta is your substitute, such that substitute theta Pi dash equal to substitute theta Pi. Okay, so this thing we can represent as P1 dash, P2 dash, Pn dash, comma, P1, P2, Pn, Q. Then we can simply substitute it theta and Q. Okay, so one example we can see is uh, like for all kings are evil, so we can find that suppose for kings are evil, we can find some x such that x is also a king and x is greedy. Okay, we can just substitute the king with some other variable. Okay, so let's say your P1 dash is King John and P1 is King X. Okay, then there will be other P2 dash is greedy, another variable y, and P2 is greedy X. Then we can substitute theta, select Q here. Theta is, we can substitute X by John and we can substitute Y by John. Okay, and here we can infer that Q is evil. Okay, so here we can finally substitute theta with Q. Okay, that means from these two lines we can just substitute Q in theta and Q. John, King John, John is greedy, so that another variable x substitute can be also evil. For both this term, we can just say John is evil. Okay. So next thing is unification. In unification, we have to know a little bit about our modifiers. There are variables. Okay, there are two types of variables here. One is your free variable and other is your bound variable. Free variable means if your variables occurs outside the scope of the quantifier. That means so example can be for all x and there exists some y, p, x, y and z. So z is your free variable here. Okay, z is free. So it is just outside the scope of your quantifiers. And bound variables means if it occurs inside the scope of quantifier, within the scope of quantifier. So here example can be like for all x, ax and by. Okay, here x and y both are bound variables. Okay, x and y both bound variables, and here g was your free variable. Okay, so next we come to the unification. So from the name itself, you can just think that unification is like something like combining two things, right? So unification is nothing but the process of making two different logical atomic expression identical by finding a substitution. Okay, unification is process of making two different logical atomic expression identical by finding a substitution. So your unification process will mainly depend on the substitution process. So it will just take two literals as input and makes them identical with the help of your substitution. Okay. So for example, let's say you have two atomic P and P1 and P2, you have two sentences and rho is your unifier. So we need to prove that your atomic expression P1 rho equal to P2 rho. Then we can express it as unify P1 and P2. Okay, so we need to find process for example unify King X and King John. Okay, so let's say P1 is your King X and P2 is your King John. Okay, so substitute means we need to find a substitution. Now theta equal to, which will replace John with X, which will be a unifier for these atoms, and apply this substitution for both expression will be your identical. Okay, now we have the process, means we have a proper algorithm for that, but maybe I'll just skip the algorithm part. Let's check if I should go for substitute algorithm part. Okay, before applying substitution algorithm, we need to follow certain rules, okay, or conditions. Even if I don't go for the algorithm part, just know the condition for unification. So first condition is predicate symbols must be same. Same, or atoms or expression with different predicate symbol can never be unified. So this is your first condition, means predicate symbols must be same. Okay, if you use different expression and different predicate, it will never be unified. Then number of arguments in both expressions must be identical. Must be identical. Then these are the two main. So your unification will fail if there are two similar variables. Present in the same expression. Okay. So these are the conditions. I will not explain the algorithm. I can give you the algorithm and notes. You guys can just check it. Just see the conditions for a while. Okay. You will get the algorithm in your notes. I'll just give you some normal examples, then you can just match with it. Okay. Suppose given that nodes gram and x. Okay. So when you are going to unify some sentence or you want to find a substitute before, you have to ask certain questions. Okay. Question means there will be a function tell and there will be another function ask, and those will just inform you or interrogate your knowledge base. Okay, so and there will be another function store and fetch. Okay, so store function is used to store a sentence into the knowledge base, and fetch function normally used to return all the unifier with some sentences. Okay, so first question will be whom does Ram knows? Question is whom does Ram knows? So Unify algorithm will search all related sentences in your knowledge base which would unify with knows Ram X. Okay. Basically, if a sentence is given, your knowledge base will simply try to relate this new fact with any other stored fact and just want to unify it so that it can conclude a meaningful sentence. Okay. For example, like it consists of unify news Ram X and knows Ram and Sham. So here we can substitute X by Sham. Okay. Then maybe it has another uh, sentence like knows Ram X and knows Y Akash. So here also we can substitute X by Akash and Y by Ram. Then maybe have another sentence unify knows Ram x and use x Raman. Here we cannot, it will fail. Okay, why fail? Because we have used the same variables for two person. We have used x for Raman and also x for Ram. Therefore, it will fail. Unification will be successful only when you use different variable for different predicates. Okay. In this case, it will not be successful because we use same variable for both Ram and Raman. Okay. So next topic, I'll just go to forward chaining. Okay, before forward chaining, there's another rule left, which is resolution in FOL. So your resolution theorem will provide a meaningful proof, or it will help you to build a refutation proof. That means proof by contradiction. Okay, it will just prove anything by contradiction. So resolution is used if there are various sentences and we need to prove a conclusion of those statements. Okay, so unification is the main key concept in proof by resolution. Okay, we use resolution if there are various statements given to us and we need to prove a conclusion of those statements. Just write from there. Okay, so unification will be a helpful process to prove by resolution. So resolution is a single inference rule which can efficiently operate on conjunctive normal form or clausal form. Okay. This is 10, okay? 10 operate on conjunctive. Or clausal form. Okay. Now, what is clause and what is conjunctive normal form? Clause means just disjunction of literals. Literals. That means an atomic sentence. Literals means here is atomic sentence. Okay. Clause means just disjunction of your atomic sentence, and it is also known as your unit clause. Unit clause. Then what is conjunctive normal form? It just sentence represented as a conjunction of clauses. Okay. Clauses. So, resolution rule for your first order logic is simply a lifted version of your propositional logic. So, resolution can resolve two clauses if they are contain complementary literals, which are assumed to be standardized part so that they share no variables. Okay, so resolution part you can represent with like L1 P up to P1 M P to P, and then we can substitute theta, theta not Q, theta becomes Q every time. 2P I minus 1, then we have P I plus 1, P K P L M to P L M N. So main thing is that we can resolve two clauses if all the variables are different. Okay, if they do not share any common variables, then we can apply resolution. Okay, for example you can see animal. One variable is loves f of x and x. Another sentence we have do not loves a, b, and also kills a, b. Okay, so here we have two complementary literals. One is loves f of x and other is does not love a and b. So these sentences are complementary to each other. So these literals can be unified with the unifier. Substitute is a unifier, right? So theta a by f of x and b by x. Okay, so it will generate a resolvent clause that animal GX kills f of x and x. Okay. So if in your two statements, atomic statements, you have like two complementary sentences, then you can just substitute it, or you can say you can just cancel out. So from these two sentences, the resolved clause can be animal GX disjunction of kills A and B. Okay. So there are certain steps for resolution. First is conversion of facts into your FOL. Then you will convert FOL into CNN. Okay. Then you will negate the statement which needs to prove. Proof means, remember, in resolution you always prove by contradiction. And finally, draw your resolution graph, which is your unification. Unification is the main key. Again, for unification, we do substitution. So for resolution and unification, the algorithm I'll provide later. Then you guys just check it. Otherwise, it is going to take lots of time to see both the algorithms. So today just here. So tomorrow we will just check forward chaining and backward chaining. Then we will just end this topic of knowledge base one. Okay. Then I can move to model and Bayesian network. Okay. So maybe I can also add up forward chaining and backward chaining for you guys. You can check both resolution steps, how we resolve sentences and how we unify sentences. Anyway, just theory part I'll explain in next class for forward chaining and backward chaining. Okay, so that's it for today. Switch on your videos. DK, Divya.
মেম মই ভিডিঅ' অন কৰিব পৰা অৱস্থাত নাই।
হয় নেকি? ঠিক আছে। ঠিক আছে বাৰু। Okay, network issue. Okay, thank you everyone. See you tomorrow.
Okay, ma'am.
Okay.